Hello, Professor. We are from Team 8 and I am Sandhya. My other teammates are Pravalika and Akhila. And today we are going to present on our project which is network intrusion detection. So basically, the network intrusion detection system is a computer software application which can detect and report network security problems by monitoring network or system activities for malicious or anomalous behavior. This network intrusion detection problem, where we have to classify each TCP or IP connection as either normal or anomalous based on 41 features obtained from the data. So next, we have chosen a data set which is which consists of wide variety of intrusions simulated in a military network environment. In this data set, the test data set has 41 total features as columns and 22,545 records as rows. And also train data set has 42 total features as column and 25,193 records as rows. So to audit the data set, first we have to start by exploring the data and its properties. Then we have to perform some basic statistical analysis on the quantitative features to check for any outliers or missing values. So these outliers and missing values is being checked in the data pre-processing. So in real world, the data we choose has many missing values or many outliers. So in order to balance the data, we are using here smart or data under sampling in order to balance the data. So by choosing this data set, we will find out how the accuracy is affected by these by applying these. And also for quantitative features, we check the distribution of the categories and their frequency in the dataset. Uh, Data pre-processing will also uh, perform multiple tasks like it removes unwanted values or missing values or null values and normalize the data, and it also converts the categorical data into numerical form. And also we are applying feature selection in this process in this data pre-processing. Next, we are going to perform exploratory data analysis. Basically, this exploratory data analysis is a process of analyzing network traffic data to gain insights and detect patterns or anomalies which may indicate potential intrusions. And also it is performed by identifying correlations and visualizing the data. uh, in order to explore this data, first perform some, we need to visualize the data and gain some insights into the data. So in exploratory data analysis, we'll be performing the statistical we will perform the statistics to describe the data for modeling. So in this, we have used the methods like count, mean, standard deviation, minimum, maximum, quartiles, uh, and so on. So next, we are performing feature selection. So feature selection in intrusion detection involves identifying the most relevant attributes or features from the dataset of network traffic data, which are most likely to discriminate between normal and malicious traffic, which also can help improve the accuracy and efficiency of the intrusion detection system. So after performing this, we will split the processed data to training and test data. So when we can train various machine learning models like decision tree, KNN, logistic regression, and naive. These are the models which we are implemented in the in our project. So in order to train and test the models on train and test the models, we have to fit every model into a we have to fit every model and then find out the accuracy and the mean score. So uh, next, the algorithms will be explained by the my next teammate Pravalika.
Hello, I'm Pravalika and I'm going to discuss about the algorithm that we have used in our project. The algorithms we have used are logistic regression, decision tree, naive-bayes classifier, and k-nearest neighbors. The logistic regression. Logistic regression is a popular statistical model used for network intrusion detection. It predicts the probability of a network packet being normal or malicious based on the values of its attributes. During training, the algorithm optimizes the weights and biases of a logistic function to minimize the difference between the predicted probabilities and actual labels. Once trained, the model can be used to classify new packets as normal or malicious. A decision threshold is applied to the predicted probabilities to generate alerts for potential intrusions. Logistic regression can provide a probabilistic assessment of a likelihood of network traffic being malicious, which can improve the efficiency and effectiveness of the intrusion detection system. However, its effectiveness may be limited if there are nonlinear relationships between the attributes and the target variable, which may require more complex models. And these are the cross-validation mean score and the confusion matrix for the logistic regression algorithm. And next we have used is decision tree. A decision tree is the most popular machine learning algorithm used for network intrusion detection. It works by recursively partitioning network traffic based on the values of its attributes to create a tree-like model that can classify new packets as normal or malicious. The tree is built by selecting the attribute that provides the most information gain at each split. During training, the algorithm may prune the tree to avoid overfitting. Once trained, the model can be used to classify new packets. Decision tree can be easy to interpret and can identify important features for the intrusion detection, but it may not perform well when there are many attributes or when there are nonlinear relationships between attributes and the target variable. And these are the values for cross-validation mean score and the confusion matrix used while for decision tree. And the next algorithm we have used is the naive-bayes. Naive-bayes is a probabilistic machine learning algorithm used for network intrusion detection. It works by calculating the probability of a network packet being normal or malicious based on the joint probability distribution of its attribute values. The algorithm assumes that the attributes are conditionally independent given the class variable, which simplifies the calculation of the probability distribution. During training, the algorithm estimates the prior probabilities and the conditional probabilities for each attribute. Once trained, the model can be used to classify new packets as normal or malicious by selecting the class that has the highest probability given the attribute values. Naive-Bayes can be fast and efficient for high-dimensional data, but it may suffer from the assumption of attribute independence and may not capture complex relationships between attributes and the target variable. And these are the cross-validation mean score and the confusion matrix when used by naive-Bayes classifier. And the next algorithm we have used are k-nearest neighbors. K-nearest neighbors is a popular machine learning algorithm used for network intrusion detection. It works by identifying the k-nearest packets to perform to a new packet based on the similarity of their attribute values. The algorithm uses a distance metric to calculate the distance between the attributes of the new packet and those of the k-nearest packets. During training, the algorithm stores the attribute values of the packets in a database. Once trained, the model can be used to classify new packets as normal or malicious based on the class labels of the k-nearest packets. The only defect of while using the KNN is maybe it may be sensitive to noisy or irrelevant attributes and can be computationally expensive for large data sets. And these is the cross-validation mean score and the confusion matrix for k-nearest neighbors. And next is continued by my teammate Akila.
I will share. Is my screen visible? Okay. So yeah, my project is network intrusion detection. So initially, we do the importing of the relevant modules. We are using matplot libraries, pandas, numpy, sklearn, and all of this. Later, we load the data into training data set and testing data set, two data sets. Using pandas, we read both of them. And then for the training data set, we display the first 4 columns. The header part basically by default displays the 5 rows, but here we used a parameter 4, so it displays only 4 rows in that. It displays all the columns in that. So this is the display of that. And later we print the number of rows and columns present in the training data. That is at the last. So training data has 25,192 rows and 42 columns. And later we do the same for the testing data set also. We display the header part for the testing data set with the 4 rows, and we display the columns and rows of testing data at the end. Testing data has 20,544 rows and 41 columns. Later comes exploratory analysis. Exploratory analysis is nothing but the description of the data set in a clear way. Here we display the count, mean, standard deviation, minimum, maximum of this. Later, we count the number of outbound commands that are the white spaces, which are not required in the coding part in the data set. So we display that, and later this is a redundant column, so we remove it from both the testing and training data sets. That is performed next. And this class attribute is the final target attribute. This class attribute is an attribute which displays whether our data that we selected is a normal data or anomaly data, which is affected by the intrusion or not. So for the training data set, this is the classification that has been done, and the normal data is displayed here and anomaly data has been displayed here. That is about the class attribute. Later, we do the scaling of numerical attributes and categorical attributes. For scaling of numerical attributes, we extract all the numerical attributes and we scale it to have 0, mean, and unit variance for the training data set and testing data set. Later, after we extract this both numerical attributes, we then turn back that attributes which we extracted into a data frame. That is done in the next part. Later, we do the encoding of categorical attributes. Here we extract the categorical attribute from both training and testing data set. We encode all the categorical attributes. Then we separate the target column from this encoded data. That has been done here at the last. This class attribute is the target column, as I told you. Later, we define the training and testing data sets number of rows and columns using shape. Then we do feature selection. We do feature selection so that we can find all the important features for modeling. So here we are using a random forest classifier on the training set. Then we extract all the important features and we do the plotting of that important features. Here is that bar graph which you can see that we plotted all the important features. These are all the important features. Then later we display all those important features that we displayed in that graph there. Here we displayed all the selected important features. There you go. And then we do the dataset partition. Dataset partition is nothing but dividing the training dataset and testing dataset. Here we do that. Training and testing. Then we do fitting models. Fitting models is nothing but we do fitting for the best to get the best model. So in our data set, I used 4 classifiers, 4 models: KNN, logistic, naive Bayes, and decision tree. So this is the classification for the I used this fitting models for training data set. This is for KNN and this is for logistic, naive Bayes, decision tree. Later, I did the evaluating of the models on our data set. This evaluating models on the 4 classifiers that I used previously: naive-Bayes, decision tree, KNN, and logistic. This later I displayed all the cross-validation mean score, model accuracy, confusion matrix score, and classification report of all of the 4 algorithms that I used. Here you can see the cross-validation mean score, and the accuracy of naive Bayes is 0.90. This is the confusion matrix. This is the classification report, the anomaly and the normal data, the precision, recall, F and support score, and everything. Here you can see for the decision tree classifier, the cross validation score is 0.99, model accuracy is 1%, and this is the confusion matrix classification report. Later for KNN, it displays the same cross validation, model accuracy, confusion matrix, and classification report. Same for the logistic regression. Later I did validating of the model. Here it displays the model accuracy, confusion matrix, and classification report after validating that model. Okay, validating that model is done using testing data set, which I did. So this is naive-Bayes classification model. These are the results: model accuracy, confusion matrix. This is for decision tree classifier. This is for KNN. This is for logistic. That's all we did. Thank you.